Hello dear students, welcome back to ArcNX. This is the second episode of shortcut series for NEET and JEE examinations, and today we're going to solve electrical circuits using Kirchhoff's junction law or Kirchhoff's current law. Now before going to the questions, we will have a brief review of the theory and I'll tell you how to apply these concepts to solving questions. Okay. Now I've taken a part of a circuit where we have a junction. Now this is called a junction where few currents are coming in and few other currents are going out. Now let us name the currents as I1, I2 and I3. These are the incoming currents, right? And there are few outgoing currents as well, I4 and I5. Now look at this. We have a junction right at this location and there are few incoming currents as well as few outgoing currents. Okay, the incoming currents are I1, I2, I3 and the outgoing ones are I4 and I5. Now according to Kirchhoff's current law or Kirchhoff's junction law, the sum of incoming currents should be equal to the sum of outgoing currents. So I can write I1 plus I2 plus I3. This is the sum of all the incoming currents. Look at this. Incoming current number 1, I1, I2, I3. All these are coming to the junction. So I can call them incoming currents. I1 plus I2 plus I3 should be equal to the sum of all outgoing currents, I4 plus I5. I can take any number of currents here, okay? And I take I4 and I5 to the left side. That makes it I1 plus I2 plus I3 plus I4 comes to the left side to become minus I4 plus I5 becomes minus I5 and that makes it 0 on the right side. Now I can write it as sigma I is equal to 0. Now this is a statement of Kirchhoff's junction law or Kirchhoff's current law. The algebraic sum of, this is called algebraic sum. The algebraic sum of currents reaching any junction is equal to 0. Or in simple words, the sum of incoming currents should be equal to the sum of outgoing currents. Now we can have an alternate statement for this. We can write this equation in terms of charges. This I1 may be written as Q1 by T. This is Q2 by T, Q3 by T, minus Q4 by T, minus Q5 by T. So all the T's are cut. You get Q1 plus Q2 plus Q3 plus minus Q4 plus minus Q5 is equal to 0. Or I can simplify it as sigma Q is equal to 0. The algebraic sum of charges reaching any junction is equal to 0. And that is the alternate statement for Kirchhoff's junction law, Kirchhoff's current law. And remember, Kirchhoff's junction law is in accordance with law of conservation of charge. We learned that Kirchhoff's second law is law of conservation of energy. Never forget, Kirchhoff's first law is law of conservation of charge, whereas Kirchhoff's second law is law of conservation of energy. Now we are going to use this to solve complex electrical circuits. Now before doing that, I'll tell you something which we learned in the first session, first episode of the series, zero potential method. How to apply zero potential to a node or a junction? If you have a common point, if no resistor or cell or capacitor is connected between 2 points, those points are considered to be at same potential. Okay? Now keep that idea in mind. Let's do the first question now. Previous NEET question. When the switch S in the circuit is closed, then the value of current I will be. Now look at this. I have a switch in the circuit here and you're going to close the switch. When you close the switch, the current flows this way, right? Okay. Now how do you proceed in such questions? I'll tell you. I'm going to assign a particular potential to this junction. I'll call it by the name X. Okay, right. And at the junction, I'll mark all the currents. I1 along the 2 ohm resistor, I2 through the 4 ohm resistor, and I3 downwards through the 2 ohm resistor. Okay, remember, you should put all the currents as outgoing. While applying Kirchhoff's junction law, this is very, very important. Take all the currents as going outwards. So you have considered a junction there and then you're taken all the currents to be going out of the junction. And one by one, you can write the currents. Before doing that, you will apply Kirchhoff's law this way. Sigma I is equal to 0, which means I1 plus I2 plus I3 is equal to 0. Okay, so I'm going to write I1 now. I1 is this current, the current through 2 ohm resistance. How to write a current? Ohm's law helps you. Voltage divided by resistance or potential difference by resistance. For this resistor, potential difference is what? The left end is connected at 20, right end is connected to X. So the potential difference must be X minus 20. X minus 20 divided by the resistance there is 2 ohms, right? I got the first current here. Plus, look at the second current, I2. I2 is flowing through the 4 ohm resistance here, right? For 4 ohm resistance, the potential difference is what? The left end of this resistor is at X and the right end is connected to 10. So the potential difference must be X minus 10 divided by the resistance there is 4 ohms. Okay, 4 ohms. Plus, as for the third resistor, this one, I can take the potential difference as this location is at X, this location is grounded or it is connected to the ground, that is earth. The potential has to be taken as 0. Even if it is not given that way, you have to take it as 0. Right. So potential difference across this resistor is what? X at the top, 0 at the bottom. So that has to be X minus 0 divided by the resistance there is 2 ohms equal to 0. Now let us simplify. LCM is 4 here. And if I want to have 4 on the denominator, I must multiply with the 2 here, right? So 2 here as well. So that makes it 2 into X minus 20 plus. Second term already has 4 on denominator. So I can retain it as such, X minus 10 plus. For the third term, I have to multiply by 2. 2 into X should be equal to 0. Now if you cross multiply, 4 times 0 is 0. That makes it 2 into X is 2X minus 2 into 20. 2 into 20 is 40 plus X minus 10. I'm just expanding this. 2X is equal to 0. So how many X's altogether? 2X, X 3X plus 2X 5X. So I have 5X is equal to, this is minus 40 with minus 10 minus 50, and that goes to the right to become plus 50. So if I cut with 5, I get X is equal to 10 volts. Now I got the potential at this location as 10 volts. The question is to find the current through the switch. The value of current I have to find this current, right? So this current was called I3, right? And I3 was written as, I'll write it here, I3 was written as, I3, this is I3, right? I3 was written as X by 2 here, right? Okay, so I'm going to take third current now. I3 is equal to X by 2. X value is already found out, it is 10, 10 by 2 is 5. So the answer is 5 amperes. Option 4 is correct. So let's go to the next one now. Find currents through all branches. Now see this, I'm going to take the potential of these points as 0. Okay, right. So for this junction, potential is 0. This one is also at 0. This one is also at 0. Now why are they at 0? Because if you walk along this path, you don't find anybody, no resistor, no capacitor, no cell. As long as you don't find any component along your path, the potential is the same at all points on the path. Okay, right. Now, if I walk along this path, you see the positive of the cell. When you see the positive, you have to lower the potential by this number, the EMF, right? So this point will be at minus 80. 0 minus 80 is minus 80. Similar way, if you walk along this point, this path, as you meet the negative of cell, you have to raise the potential by 40. So this point is going to be at 40 volts. Okay, and for this point, I call the potential X. This one is also at X. This one is also at X. Okay, so all these points are at X because, as I said earlier, there is no component connected across the points along that path. So I have marked everything now. I'm going to apply Kirchhoff's junction law to a particular junction. Look at this. I'm going to take this junction. I'm going to call this current by the name I1. This current is I2 and this current is I3. What is Kirchhoff's junction law? At this junction, sigma I is equal to 0 or I1 plus I2 plus I3 is equal to 0. What is I1 here? I1 is the current through this resistance, right? You have to write it as potential difference by resistance. What is the potential difference across this resistor? Left end is at X, right end is at 40. So, X minus 40 divided by the resistance there is 40. Right, 40 plus. And for the second current, I2, the potential difference between the points is what? The left end of this resistor is at X, right end is at 0. So the potential difference between these 2 points is what? X minus 0. X minus 0 divided by the resistance along that path is 30. So I put it right into this plus, and for the third current, this is the third current I3, right? For this resistor, the left end is connected to X, right end is connected to minus 80. So it is X minus minus 80 divided by the resistance on that path is 40. So 40 should be equal to 0. Here the LCM is 120. I'm going to put it here 120. And on the numerator, I'm going to multiply this with the 3. 3 into 40 is 120 now. So I'll put 3 here. 3 into X minus 40 plus. And this has to be multiplied with the 4. Because 4 into 30 is 120. So 4 times X plus. And the last one also has to be multiplied with 3. Because this is 40. I have to make it 120. Yeah? So I'm multiplying with the 3. 3 into X plus 80 should be equal to 0. And like before, I'm going to cross multiply, which will make the right side equal to 0. So what am I getting now? 3 times X, 3X minus 3 times 40, 120 plus 4X plus 3X plus 240 is equal to 0. Simplifying further, 3X plus 4X, 7X plus 3X, 10X. 10X is equal to this 3, 240 and minus 120. It is 120. That goes to the right side to become minus 120. And if I cut zeros on both sides, I'm getting what? X is equal to minus 12 volts. Okay. Now having obtained the value of potential at all these points, I can easily find the currents. What is I1 here? I1 is this, X minus 40 by 40. I2 is this, X minus 0 by 30. I3 is this, X minus minus 80 by 40. So I'm going to find I1, I2, I3 now. Look at this. I1 is equal to what? X minus, see this is I1. Okay, X minus 40 by 40. X minus 40 by 40. X is minus 12 minus 40 by 40. And that's going to give you minus 40 minus 12 minus 52 by 40 is minus 1.3 amps. Do not worry about the negative sign you got here, because negative sign appears because the presumed direction is wrong. We thought the direction of current to be this, but actually the current flows in opposite direction. Okay, so do not worry about the sign there. Now I2 is what? Second current I2. I2 is this current, which is X by 30. X divided by 30, X is minus 12 by 30. If I cut with 3, it is minus 4 by 10 or minus 0.4 amps. See, that is again negative, right? And for I3, I can take I3 this way. This is I3, third current I3, which is X minus minus 80. X minus minus 80 by 40. X minus minus 80 is plus 80 by 40, which is equal to what? Minus 12 plus 80 by 40, which is minus 68 divided by 40, and that's going to be 1.7 amperes. That's positive, right? So let us check if it is correct. Look at that. First current is what? Minus 1.3. I1 is minus 1.3 is coming this way. Then minus 0.4. Minus 0.4. It is coming this way. So 1.3 is coming this way. 0.4 is coming this way. They join together to become 1.7. That's correct. Okay. Moving to the next one now. Find the current through 6 ohm. There are different methods to do this, but I'm going to use this Kirchhoff's junction law for this. Right. So look at this. I'm going to take the potential of this location as 0. And as I walk, I see the negative. So I'm raising it by 20. So this point is at 20. Or rather, this point is at 20 volts. This point is also at 0. Look at that. This is 0. This is also 0. And if I come along this is negative. So I'm raising the potential by 20. This point is at 20. And I'm going to call this particular point's potential by the name X. I have 3 currents there. I1 along this, I2 along this, and I3 through this path. I had already told you to take all the currents as outgoing. All the currents are going out of the junction. You should be taking that way, right? So I'm going to apply Kirchhoff's junction law. What is Kirchhoff's junction law? Sigma I is equal to 0, or I1 plus I2 plus I3 should be equal to 0. What is I1? Look at this. This is I1, right? How to find I1? Oh, no. This is I1, right? How to find I1? Potential difference by resistance, Ohm's law. What is the potential difference across this resistor? The left end is connected at X. Right end of this is connected at 0. So the potential difference is X minus 0 divided by, divided by the resistance along this path is 6. X minus 0 divided by 6 plus. I'm not done yet. Second one, for I2, how to find I2? Potential difference by resistance again. For this resistor, the left end is connected at X, the right end is at 0 potential. So left end is at X, right end is at 0. So the potential difference is X minus 0 divided by the resistance there is 3 ohms plus. Third one, for the last current, this resistor has its right end at X, left end at 20. So X is the right side potential, left side potential is 20. So potential difference is what? That's going to be X minus 20 divided by the resistance is 4, right? 4 should be equal to 0. I'm going to take LCM again, like before. LCM here is 12. I'm going to make it 12 everywhere, so I must multiply with the 2 here, right? So 2 times X plus. Second one, I'll multiply with the 4 here. So on numerator also 4 times X plus. And this has to be multiplied with the 3. So this is also multiplied with the 3. 3 into X minus 20 should be equal to 0. Cross multiplying again. Expanding, I get 2 into X 2X plus 4 into X 4X plus 3 into X 3X minus 3 into 20 60 is equal to 0. 2X plus 4X 6X plus 3X 9X is equal to minus 60 goes to the right side, it is 60. X is what now? 60 divided by 9, or it is 20 by 3 volts. Now I got the potential at this location. Now it is easy to find the current through 6 ohm. Current through 6 ohm. Current through 6 ohm is what? I1. How to find I1 here? Look at this. This is I1, right? How to find I1? I1 is nothing but X minus 0 divided by 6. I1 can be written as X minus 0 by 6, that is X by 6, which is 20 by 3 by 6, which is 20 by 18, or it is, I'll write it here on the left side, 20 by 18. So I1 should be equal to 20 by 18, 20 by 8. If I cut it with 3, that will be 20, not 2, that will be 10 divided by 9, 20 by 80, 20 by 2, 10, 18 by 2, 9. So 10 by 9 amps. So that will be the answer to this question. So I can, similar way I can find the current through this by taking I2. I2 is what? X by 3. And I3 is what? I3 is x minus 20 by 4. I can find all the currents in the circuit now. Okay. Now see the next one. I think this one is the last one. Right. Oh, we have one more. Right. Find current through 6 ohm resistance. Again, like we did before, I'm going to put the potential at this location as 0. So as I walk, I meet the negative of cell. So I have to raise it by 4.5. So this end comes to be at plus 4.5, right? Or even this end is also at 4.5, because along this path, no resistor, no capacitor, no cell. Okay. So if this is 4.5, everywhere it is 4.5. And for the junction, we take the potential as X. Okay, right. And this is 0. And as you walk up, it is 0, 0, 0 everywhere, right? So I can put 0 here as well. This one is also 0. Right. And if I walk to the left, I see the negative of cell. Negative of cell means I have to raise it by 3. So this point will be at what potential? At 3. Okay. Now I can apply Kirchhoff's junction rule to this location. Okay. What is Kirchhoff's junction rule? I1 plus I2 plus I3 should be equal to 0. I1 plus I2 plus I3 should be equal to 0. Okay. I'll call this current by the name I1, and this one as I2, and this one as I3. And we have to proceed exactly the same way we did in the previous case. I1 is what? For I1, the left end is X, right end is 0. So that is X minus 0 divided by the resistance there is 6 ohms. Okay. Plus, for I2, this is I2, right? The left end of this resistor is at X, right end is at 3. So that makes it X minus 3 divided by the resistance on that branch is 10. Plus, for the third one, for this current, the left end of this resistor is at 4.5, right end is at X. So the difference, potential difference is X minus 4.5 divided by the resistance along that path is 3. It's equal to 0. Nothing. I have taken Ohm's law, where current is found out using the equation V is equal to I into R, or I is equal to V by R. Now I can simplify this further. I take the LCM as 30. Okay. So I'm multiplying with 5x. That makes it 5x. Second one 3 times x minus 3. And third one 10 times x minus 4.5. Should be equal to 0 on the right side, right? Okay. Now I cross multiply. The right side is going to be 0 again. And if I simplify, I'm getting 5x plus 3 into x. 3 into x, 3x, 3 into 3, 9. So 5x plus 3x minus 9 plus 10x minus 45 is equal to 0. X's are taken together. 5x plus 3x is 8x. 8x plus 10 is 18x is equal to 45 and 9. 45 and 9, 54. And that goes to the right to become plus 54. If I cut with the 3, I'll get, if I cut with the x, I'll get x is equal to 3 volts. I got the potential at this junction. Okay. Now the question is to find the current through 6 ohm resistance. Current through 6 ohm resistance is called I1. So my job is to find I1 here. How to find I1? Look at this. This is I1. I1 is this x minus 0 by 6, right? So I can write here I1 is equal to x minus 0 by 6, or it is x by 6. That will be 3 by 6, which is equal to 1 by 2 amps. Okay. Similar way you can find out I1, I2, I3 as well. If you try finding I2, I2 will be what? Let's check. I2 is this x minus 3 by 10. X is 3 here. So 3 minus 3 by 10. 3 minus 3 is 0, no? So this current will be 0. So obviously this current will be what? 1 by 2. You check it out, I3 will be 1 by 2. Because I3, 1 by 2 flows this way. Nothing flows in this direction. So the entire current has to flow this way. Check it out. Okay, you can do it yourself. But the question here is to find current through 6 ohm only. That's why I thought of finding I1 alone. You can try doing the rest, I2 and I3 yourself, and you will see that this current is 0 and this current is also equal to 1 by 2 amps. And the last question here, find currents in all branches. I'm leaving this as an assignment for you. Try this at home. But as I told you before, you have to take a common point. This is a common point where the potentials are same. At this location, potential is 0, this is 0, this is 0. And if I walk along this, I meet the negative of cell. That means I have to raise it by 8. So at this point, the potential has to be written 8. Okay, for the second point, if I walk along this, again I encounter negative of the cell, which means I have to raise the potential by that number. That's going to be 10 there, right? And for the third part, look at this, again negative of the cell, which means the potential has to be increased by 6. So this point is going to be at 6. And for the common point, I call the potential by the name X. Okay, and right into this, you can apply Kirchhoff's junction law, which tells you what? I1, I'm going to call this current I1, this current I2, and this current I3. Okay, and at the junction, you can say that sigma I is equal to 0, or I1 plus I2 plus I3 is equal to 0. Okay, now you have to proceed exactly the same way we did before. Try writing all the currents and then solve it for X. Once you have found the value of X, put them back into the equations so that you can find all the currents. Okay, and try to solve this yourself and leave the answer in the comment part. And I'll come back with more sessions of this kind. We'll have more sessions and practice all these questions. These are very important ones for NEET and JEE examinations. So meet you in the next episode. Till then, bye.